Have you ever wondered? In the observable universe, there are roughly 10 to the power of 22 stars. Why, out of all places, did life happen to emerge on Earth? And why, it seems, only this once? If we are the only life, it seems almost too incredible to believe. That's why humanity has never stopped thinking, do aliens exist? If so, where are they? And do they look anything like us? Over the next 40 minutes, let's explore the existence of extraterrestrial life, and even civilizations, from multiple angles. We hope this video takes you on a delightful journey into the search for alien life. To begin our search for extraterrestrial life, we first need to tackle a fundamental question. What exactly counts as life? Life on Earth is incredibly diverse, from towering trees to microscopic bacteria, from crawling creatures to ourselves. It's a veritable menagerie of life. We usually consider something alive if it can eat, excrete, move, grow, reproduce, and react to its environment. In simple terms, a species that can find food, develop, and procreate. Even plants turn towards the sun, flower, and set roots to grow. But some things are more ambiguous. Take viruses, for example. A virus can't do anything on its own. It has to hijack a host cell to reproduce. So, is it alive? The scientific community is fiercely divided on this. Therefore, we shouldn't confine our thinking to Earth standards. What if aliens drink methane instead of water? We have to think outside the box. For our purposes, let's broadly include anything that strives for survival and reproduction. That said, while the definition of life can be broad, we can actually make some educated guesses about what aliens might look like. Scientists and sci-fi authors have imagined little green men, rock monsters, and even beings of pure energy. Even astrophysicist Neil deGrasse Tyson thinks energy beings aren't out of the question. But which is more plausible? This depends on a hard truth. Form follows function. Look at our own bodies. They are practically nature's top-of-the-line model. 2 hands for fine manipulation, an efficient digestive system, 2 legs for swift movement, a superbrain, and a workhorse heart. Every part is tailor-made for a specific function, honed over billions of years of refinement. Nature, as a designer, excels at survival of the fittest. Charles Darwin understood this on the Galapagos Islands, where different finches had different beaks, all adapted for eating specific foods. This is evolution. The environment selects for useful traits, which are then passed down. Take sight, for instance. Light is everywhere. Any creature that could develop eyes gained a massive head start. Vision is so incredibly useful that nature has independently invented the eye about 40 different times. This is called convergent evolution, different species solving similar problems by evolving similar equipment. For example, bats and birds both fly. Bats and dolphins both use echolocation. Even a koala's fingerprints are remarkably similar to ours. Why? Because some survival pressures are universal. A good idea is something nature might reuse in different exams across the cosmos. So, on a planet with an environment similar to Earth's, aliens might actually look quite a bit like us. We used to think aliens in sci-fi movies looked human out of laziness. Now, it seems the humanoid design might just be a blockbuster hit across the universe. Think about it. A civilization capable of interstellar travel would need to use tools. That makes something like fingers for manipulation highly likely. Paired with a large head housing a super CPU for thinking, that's probably standard equipment too. With a smart brain, maybe they, like us, no longer rely on fur for warmth but wear spacesuits instead. Of course, this is an absolute. If an alien planet's environment is vastly different from Earth's, the life that evolves there would surely be bizarre and varied. Low gravity might lead to towering giants. High gravity might produce short, stocky beings. A dimly lit world might result in creatures with searchlight-like eyes. Large temperature swings could create masters of hibernation. In short, life will always find a way to adapt to its environment. This is the ultimate power of form follows function. Speaking of adapting to environments, we must mention Earth's own masters of survival, extremophiles. These tiny organisms thrive in places we consider completely uninhabitable, scalding hot springs, arid deserts, hypersaline lakes, and even areas with deadly radiation and heavy metal contamination. They survive thanks to their black tech, highly specialized body structures and chemical processes. These alien neighbors on Earth are like a treasure map for our search. Many of these hellish environments on Earth are remarkably similar to conditions on other planets. For example, Chile's Atacama Desert is practically a stand-in for Mars. Scientists have found life there, which points us to the most promising nooks and crannies to search on the red planet. By studying these survival experts, we can better predict what kinds of life forms are plausible in the universe and where we might find them. If life can spring up in such harsh places on Earth, it's entirely possible in similar environments on other worlds. Of course, life isn't invincible. In multi-thousand-degree lava or the vacuum of space, even the hardy water bear can only enter a suspended state. It cannot survive indefinitely. This brings us to a key question. What kind of prime real estate is needed for alien life to settle down and thrive? And what kinds of death traps could extinguish the spark of life before it even begins? The hard requirements for life start with temperature. A planet needs to be in the habitable zone, where it's just right. But this isn't an absolute guarantee. Venus is on the edge of the habitable zone, yet it's hot enough to melt lead because of its runaway greenhouse atmosphere. So, the atmosphere is also critical. Then there's water. Life on Earth is inseparable from water. While aliens could theoretically use other liquids, not a single known organism on Earth can live without water. So, it's likely a universal requirement. Another crucial factor is the host star. Our Sun is a yellow dwarf, relatively stable with a decent lifespan, which has allowed life on Earth to flourish. But yellow dwarfs are a minority in the Milky Way. The most common type of star, making up 75%, is the red dwarf. These stars have incredibly long lifespans, but they also have many problems. Their habitable zones are very close to the star because they aren't very bright. Being close isn't inherently a problem, but red dwarfs have violent tempers. They frequently erupt with flares hundreds or thousands of times more powerful than the Sun's, capable of stripping away a planet's atmosphere and boiling off its liquid water. Even if a planet survives these outbursts, it's likely to be tidally locked, with one side perpetually scorching and the other frozen solid. The extreme temperature difference makes it impossible to retain an atmosphere. Furthermore, their magnetic fields may be weak, offering little protection from cosmic radiation. To live near a red dwarf, you'd probably need to buy sunscreen by the ton. So, all things considered, if alien life exists, it most likely arose around a stable, bright star like our Sun, on a planet with a suitable temperature, liquid water, and a protective magnetic field. Actually, we don't have to travel light years to find such environments. It's possible that right here in our solar system, life may have sprouted more than once. First, Mercury. Its atmosphere is thin, and it's too close to the Sun. Daytime temperatures can soar to over 400 degrees Celsius (750 degrees Fahrenheit), while at night they plummet to minus 170 degrees Celsius minus 275 degrees Fahrenheit. Although there's evidence of past geological activity, the last volcanic eruption is believed to have been 1 billion years ago. Mercury's history has surely seen many extinction-level events, essentially eliminating any chance for life to develop. While some water ice can be found in permanently shadowed craters at the poles, our theory holds that only liquid water can support life. So, life on Mercury is a long shot. What about Venus? It has a very thick atmosphere, but it's still not far enough from the Sun, just grazing the edge of the habitable zone. The entire planet is over 400 degrees Celsius (750 degrees Fahrenheit), and its atmosphere is 96% carbon dioxide. This intense heat means no liquid water can exist on the surface. However, scientists have found some suspicious signs high in its cloud layers, such as phosphine, which on Earth is exclusively produced by microbes. So, it's possible that some heat-resistant microorganisms are hiding in Venus's clouds. It's an interesting possibility. We'll skip Earth for now and perhaps discuss the origin of life here another time. Moving outward, we come to Mars. It's in the habitable zone and has an atmosphere. But Mars' biggest problem is its lack of a protective magnetic field. As a result, its atmosphere has been almost entirely stripped away, leaving behind mainly the heaviest molecules. It's now 96% carbon dioxide. While Mars definitely had surface water in its history, the dried-up riverbeds and lakebeds are proof that water is gone today. If life ever existed on the surface, it has likely vanished as well. Scientists have been eager to find evidence of life in Martian rocks, but so far, they've only found tantalizing clues. They haven't given up, though. The search for Martian life is a top priority, which clearly indicates they believe they'll find something. After all, there are signs that life may have existed, or might still exist, on Mars. We also have dozens of Martian meteorites, our only samples from the planet. A few of these contain structures that look like fossilized bacteria, but this isn't definitive proof, as these structures could also be formed by natural geological processes. Currently, there are two likely places to find life on Mars. One is about 10 meters below the surface, where water might still exist in liquid form. The other theory is that microbes could exist under the polar ice caps. With the current high level of interest in Mars exploration, we should have a definitive answer on whether there's life there within the next 30 years. Further out is Jupiter. Its environment is so hostile that the probability of any known life form existing there is virtually zero. But its Galilean moons are a different story entirely. They might just be oases of life. Around 2030, the Europa Clipper mission will arrive at Jupiter, heading for its moon Europa. This is one of the most promising places to find life in the entire solar system, not on its surface, but beneath it. Europa's crust, made of water ice, is covered in strange fault lines. Below this ice crust is believed to be a global ocean of liquid water. Evidence for this includes the rotation of the crust, which is thought to have shifted by as much as 80 degrees, something nearly impossible if the crust were rigidly attached to the core. Reanalysis of data from the early Galileo spacecraft and subsequent observations by telescopes like Hubble suggest that Europa may have water vapor plumes or geysers erupting far into space. When NASA's Europa Clipper arrives, it will orbit Europa, fly through these plumes, and sample the ejected water. We don't expect to find fish in the fountains, but the water samples will tell us about the conditions under the ice and whether life could truly exist there. While Europa is the most likely candidate around Jupiter, it's not the only moon with a potential subsurface ocean. Ganymede and Callisto may also have them. Ganymede is particularly interesting because its ocean might be in contact with a rocky seafloor, which could provide the necessary minerals for life, similar to Earth's deep-sea hydrothermal vents. The European Space Agency's JUICE mission is set to arrive at Jupiter in July 2031 to study these icy moons. Besides Jupiter, some of the icy moons of Saturn, Uranus, and Neptune have similar potential for subsurface oceans. But the most exciting of all is Enceladus, a small moon of Saturn. It's a veritable supergeyser, constantly spewing water and organic materials, including the key elements for life: carbon, hydrogen, nitrogen, and oxygen. What's more, there's a heat source under its ice shell. It's the perfect recipe for life. It's not an exaggeration to call it the most likely place to find life in the solar system. Unfortunately, while there are proposals for missions to Enceladus, they are still a long way off. Beyond these planets and their moons, dwarf planets like Pluto, Ceres, and Sedna might also have liquid water oceans beneath their surfaces if they follow the pattern seen in larger moons. There are two final intriguing places to look for life in our solar system. The first is Saturn's largest moon, Titan. It's freezing cold, but it has a thick atmosphere and lakes and rivers of liquid methane on its surface. It's a world of liquid methane. In theory, a life form could exist that uses liquid hydrocarbons instead of water. This hypothetical organism would breathe hydrogen instead of oxygen, metabolize acetylene instead of glucose, and produce methane instead of carbon dioxide. Titan is often compared to early Earth. NASA has a mission called Dragonfly, a rotorcraft set to launch around 2028 to explore Titan's unique methane environment. If it captures footage of something swimming in a methane lake, it will undoubtedly shake the world. The last place to search for life in our solar system is on comets. Some theories propose that comets are the universe's seeders of life. While unlikely, scientists have discovered complex organic molecules, the building blocks of DNA, on comets. However, there's a huge leap from organic molecules to a living organism. Comets might be good for a ride, but it's probably too much to ask for life to originate on one from scratch. In summary, aside from the inhospitable places, our solar system has quite a few locations with the potential for life beyond Earth. But for now, they are all just possibilities, with no definitive proof. When we cast our gaze to the entire universe, we have to mention the famous Kepler Space Telescope. It opened the door for us to explore exoplanets, these new continents in the cosmic deep. You might wonder, since we can't even get a clear picture of an exoplanet, the best we have looks like a smudge, how do scientists discover them and know they might host alien neighbors? This is thanks to planet hunters like the Kepler Space Telescope. Their method is quite clever. They stare at a large patch of stars and watch for periodic dimming. If a star's light blinks regularly, it means a planet is passing in front of it, blocking some of the light. From the frequency and depth of this dimming, we can calculate the planet's size and orbit. Kepler was a champion, finding thousands of exoplanets for us. Before it, we knew of only a handful, mostly gas giants larger than Jupiter. Now, its successor, the TESS telescope, is expected to find tens of thousands more. Scientists estimate that our Milky Way galaxy alone could have over 100 billion exoplanets. Once a planet is discovered, the next step is a health check to see what's in its atmosphere. This relies on analyzing the starlight that reflects off or passes through the planet's atmosphere, a technique called spectroscopy. Just as white light splits into a rainbow through a prism, starlight passing through a planet's atmosphere is altered. Certain gases in the atmosphere will emit specific colors of light, leaving a fingerprint on the spectrum. Through these fingerprints, we can tell if the atmosphere contains gases related to life, like oxygen, water vapor, and methane. If an exoplanet's atmospheric composition is somewhat similar to Earth's, it has a good chance of being a habitable new Earth, perhaps already home to life. Even more, if there's an intelligent civilization, the pollution from their factories or the smog over their cities could leave traces in the spectrum. So, have we found any such candidates? We have. Among the exoplanets discovered so far, 59 are considered rocky planets comfortably situated in their star's habitable zone. Of course, this doesn't guarantee life. We need more evidence. But excitingly, clues are beginning to emerge. This brings us to biosignatures, substances or patterns that can provide evidence of life. These can be direct, like fossils, or indirect, like atmospheric components. They can be broadly divided into three types. Gaseous signatures, gases produced by life's metabolism. For example, a hazy atmosphere might indicate a world rich in methane, possibly hosting microbes similar to those on Earth billions of years ago. Or if there's free oxygen in the atmosphere, it's very likely that plants are performing photosynthesis. Temporal signatures, patterns related to biological activity that change over time. For example, on Earth, carbon dioxide levels fluctuate with the seasons because plants grow in the spring and decay in the fall. In theory, observing such changes could help us pinpoint where life is most active on an exoplanet. However, we must be cautious, as some changes could also be due to natural factors. Surface signatures. This is the most interesting one. Different surface materials reflect starlight differently. By analyzing this reflected light, we can tell if a planet's surface is rock, snow, water, or soil. Life can also alter the reflective properties of a surface, leaving a unique signature. Speaking of which, we have to mention a thrilling discovery. The James Webb Space Telescope detected possible signs of dimethyl sulfide, DMS, in the atmosphere of the exoplanet K2-18b, about 124 light-years away. This finding, first announced in 2023, garnered widespread attention because on Earth, DMS is primarily produced by life and is considered a potential biosignature. While scientists are very cautious, emphasizing that this is not direct proof of alien life and requires more observation, the discovery has undoubtedly given our search a huge boost of optimism. After all, it's one thing to say aliens might exist. It's another thing entirely to say we might have already seen signs of their existence. These potential signs of life fill our imagination with the possibilities of the cosmic landscape. So, what if this life isn't just microbial, but has evolved into a civilization as advanced as, or even more advanced than, our own? Think about it. Once an alien species evolves intelligence, it likely did so by outcompeting rivals and gathering resources for itself and its offspring. A civilization composed of such beings would likely have a strong desire for space and resources. Whether they acquire these through clever diplomacy or through aggression, they will likely want them. Just like the form follows function principle we discussed, this principle also applies to cultures and civilizations. This inevitably leads us to the Kardashev scale, a system for classifying different types of alien civilizations. It divides civilizations into three types. Type 1 civilization can harness all the energy available on its home planet. As a species, we humans haven't quite reached this level yet. We're at about a 0.7 on the scale. Type 2 civilization can harness all the energy of its host star, possibly by building megastructures like a Dyson sphere to capture its entire energy output. Type 3 civilization can harness the energy output of its entire galaxy. We have not seen any evidence of a civilization like this, which is probably a good thing. They might view us the way we view bacteria. Interesting, but fundamentally insignificant. After Kardashev, other scientists have expanded the scale. Type 4 uses all the energy in the universe. Type 5 uses all the energy from multiple universes. and the mysterious Omega-type civilization, capable of tapping into energy beyond all this, perhaps existing entirely outside of time. Such a civilization would essentially be a god. We would have no way to detect them, because everything in the universe would exist only as they wish it to. We have nothing to compare their existence to. Assuming we did encounter another alien race, according to this theory, we would almost certainly compete for resources in some way, or be crushed by a much more powerful force. This sounds like a bleak prospect, but there are other possibilities for civilizational development. After all, not all humans desire constant outward expansion. In fact, with the rise of the internet and cyberspace, more and more human interaction is happening in the virtual world. Carl Sagan proposed a model that classifies alien races based on the amount of unique information they have gathered. While this is much harder for us to detect from a distance, and certainly difficult to measure, this way of measuring progress doesn't require a species to expand infinitely. An intelligent species that begins to explore inward, even one that spends all its conscious time in some kind of cyberspace, could still learn more and more about itself from the entire universe while physically occupying less and less space. By the way, Carl Sagan's scale is alphabetical. It's estimated that in 1973, we were roughly a Type H civilization because we knew about 10 to the power of 13 bits of unique information. 50 years later, we've likely progressed a bit further up the scale. But for comparison, a Type Z civilization would need to know 10 to the power of 31 bits of information, which is more information than exists in the entire universe. So such a race is unlikely to exist, at least not yet. So, a super civilization like Type Z that has mastered all the information in the universe is still too distant and even hard for us to imagine. Putting aside these godlike civilizations and returning to our more realistic search, even for a less advanced intelligent civilization, there are many hurdles to overcome from their birth until they can be detected by us. A lot of things have to go right for them to reach that level of intelligence. And if we want to spot them in the night sky, the chances are even slimmer. Let's review. To begin with, they likely need a suitable starting orbit. As far as we know, life cannot exist without energy. They need a planet that is suitable for them. They would likely compete with other life forms for limited resources, driving them to adapt and advance. Over time, they need to develop problem-solving skills and intelligence as a way to acquire these resources and defeat competitors. Then, their civilization must manage to survive, not being wiped out by an accidental asteroid impact, earthquake, or global freeze. They must also not self-destruct. They must invest in technology and develop it to a level that allows them to communicate across the cosmos. They must also have the desire to communicate with any potential neighbors, rather than being extremely isolationist. Finally, they would need to be continuously broadcasting a signal in our direction for long enough for us to detect them. None of this is a given. However, as astronomer Frank Drake pointed out at the first SETI conference in 1961, all of these factors can be used to calculate the probability of us finding alien life. He put all his ideas into the famous Drake equation. While elegant, many of its variables are unknown, leading to results that range from almost no communicable civilizations in the galaxy to potentially millions. This makes it possible that the universe is either dead silent or teeming with life. If it's the former, we might have to prepare for a long, lonely existence. We'll have to learn to get along with each other, because we are all the life we will ever see. No aliens will be dropping by to say hello. We bear an even greater responsibility to protect life on Earth, because it's likely no new life will come to replace it. But if it's the latter, then space should be filled with alien races, ready to be discovered at any moment. So where are they? This is the famous Fermi paradox. The answers are varied, some plausible, some wild, and some downright chilling. Possibility 1, there are no aliens. If the origin of life or the evolution of intelligence is harder than winning the lottery jackpot, then it's normal for the universe to be empty. We might be the only kids on the block, destined to play by ourselves. Possibility 2, the cosmic delivery service is too slow. The signals haven't arrived yet. To chat with aliens, either we shout and wait for an echo, or they have to greet us first. Sending spaceships is too slow. A trip to our nearest neighbor would take tens of thousands of years. So, the most reliable method is radio signals. But the speed of light is also a limit. We haven't had radio technology for very long, so the range we can communicate over is tiny compared to the entire galaxy. So maybe it's not that there are no aliens, but that we just got online too late, or their reply is still on its way. Possibility 3. The signal arrived, but we didn't recognize it. Aliens might greet us in ways we can't even imagine. No matter how creative scientists are, they might be missing something. For example, the famous "wow" signal from 1977 was a one-time event, and its origin is still a mystery. And there's the mysterious SHG signal and the periodic fast radio bursts, FRBs. Maybe these are alien social media updates that we just can't decipher. Possibility 4. Aliens are already here. We're just blind to them. This is a bolder claim, suggesting that UFOs are alien spacecraft. But the evidence for UFOs has always been weak, with too many fakes and misidentifications. Some even say it's government disinformation. So we can't just blame aliens for things we don't understand. However, if a UFO were ever confirmed, it would be world-changing. And look, even governments are starting to study UFOs seriously now, which suggests there might be more to it than we think. Speaking of UFOs, we have to mention Kenneth Arnold's flying saucer sighting in 1947. Since then, sightings have been continuous. But what counts as solid proof? In short, it needs to be recorded by multiple people and multiple devices, rule out all known possibilities, and preferably be repeatable. The 2004 incident where the USS Nimitz carrier group encountered the Tic Tac UFO fits these criteria well. It was witnessed by 4 pilots and recorded by radar and video. The object moved far faster than any of our aircraft. The US government later acknowledged the authenticity of the video. And this wasn't a one-off event. Navy pilots have encountered more and more strange things, with reports piling up. The accuracy of these reports is, of course, unknown. So what are these objects? Their nature, and perhaps their origin, may vary. The things being witnessed come in all shapes and sizes and behave strangely. Some are like long-endurance drones that can signal each other. Some move like a squadron of aircraft with terrifying acceleration. Some can fly in the air and then dive into the water. Others look like balloons but can hover in place or even fly against the wind. Of course, among these many sightings, some are surely technical glitches or misidentifications. For example, the famous triangular UFOs were later found to be a possible optical illusion caused by night vision goggles. But even so, there are still phenomena that have the military stumped, like the drones that loiter over military exercise areas. What are they trying to do? It's a concerning question. To treat this more seriously, the Navy later renamed these objects UAPs, unidentified aerial phenomena, and more recently, unidentified anomalous phenomena. The point is, let's not jump to conclusions about aliens, but let's not rule it out either. The US government has even held congressional hearings and regularly reports investigation progress to the public, as long as it doesn't leak classified information. They are now working hard to collect data to figure out what's going on. This shift in attitude is what's most interesting. Of course, we must be clear-headed. Although we've analyzed all this and think alien life is plausible, as of today, there is no hard proof that they exist, nor that they have come to Earth. So, let's speculate on how an alien civilization might behave. Broadly, we can think in 2 extremes. One is extremely friendly and helpful. The other is aggressive and believes in survival of the fittest. Let's start with the less optimistic one, violence and aggression. If we look at our own human history, fighting over land, resources, and people has been constant. This aligns with the principles of evolution. Resources are limited, populations grow, and competition is natural. Even if our technology advances enough for us to travel to space, this habit probably won't change. After all, aren't we clamoring to break out of Earth, even as conflicts on our planet persist? So, using ourselves as a reference, we have to consider that if aliens exist, they might be just like us, plundering resources for their own survival and development. Of course, the reasons for war aren't just about resources. Different beliefs and ideas can also lead to conflict. Look at the Cold War. It was driven by ideology. Aliens' ways of thinking will certainly be different from ours. If they feel our ideas threaten them, conflict could erupt. Not to mention, some civilizations might be naturally warlike, believing that victory brings honor, or that it's faster to take from others than to work hard themselves. For an intelligent species that has already conquered its own planet and defeated all its rivals, these are all perfectly normal thoughts. Survival feels good. Being powerful feels even better. But if this thinking leads to conflict, what would an alien war look like? The more advanced the technology, the more terrifying the war. We currently don't have the ability to throw things into other solar systems. The universe is vast. Unless we're content with yelling insults at each other across space, to actually fight, we'd first have to solve the problem of faster-than-light travel. But if that problem is ever solved, things get dangerous. Think about it. While accelerating something with mass to the speed of light is theoretically impossible, if you could accelerate an asteroid-sized object to near the speed of light and hit a planet with it, the instantaneous release of energy would wipe out all life on that planet. And there would be no time to react. Any intelligent species would understand the power of this move. We just have to look at what happened to the dinosaurs. Alien warfare might not need nuclear bombs or armies. Just throwing a few fast-moving rocks would be enough. This provides an explanation for the Fermi paradox, the dark forest theory. If advanced alien civilizations exist and they understand this tactic, then other aliens might conclude that staying silent is the safest bet. The moment you reveal your position, you're painting a target on your back. What if the other side doesn't trust you and decides on a preemptive strike? The universe is like a dark forest. Everyone is hiding quietly. You're either silent, or you've already been eliminated. Of course, this isn't the only explanation. Another possibility is that aliens are simply indifferent to us. The universe is ancient. The technological gap between us and other potential life forms could be immense. To them, we might be like ants. There's nothing to talk about. The gap is too wide for us to even comprehend their thoughts. On the other hand, life in the universe might be quite rare. If they really need resources and are that much more advanced, they probably don't need to come and take ours. Earth's resources are trivial. We might just be a curiosity, a specimen in a cosmic zoo, protected and allowed to develop on our own. The zoo hypothesis. After all, a zoo tries to replicate an animal's natural environment. While they may not care about us, they also don't want to scare us. Of course, if we accidentally provoke them, the consequences could be dire. It's like an ant crawling into your kitchen. You know how that ends. These two ideas, either violent conflict or complete indifference, are both rather discouraging. So you might be happy to hear that besides hatred and indifference, there is another option, and for a more advanced society, it might be the most realistic one: cooperation. Cooperation is common in nature. Wolves hunt in packs. Ants form vast colonies. Humanity is where it is today entirely because of cooperation. Sharing knowledge drives technological progress. Think about it. Who today could build a computer from scratch? It's all based on the division of labor among people in different fields. Historically, we humans have indeed become better at cooperating. It started with small tribes fighting, then kingdoms, then nations, and now we have multinational alliances. If this trend continues, maybe one day all of humanity can unite to form a federation of Earth. So why is cooperation more likely than violence? Simply put, once technology reaches a certain point, it forces you to cooperate. The easier it is to communicate, the fewer the barriers. And when everyone has world-destroying weapons, the only choice besides sitting down and talking is mutual annihilation, which is not a great option. So, aliens may have walked the same path. If so, how would they treat their cosmic family? At first, they might be wary of outsiders. But eventually, they might come to see new alien races as brothers and sisters, building a galactic community together. After so many eons, they may have grown weary of war. The universe might be filled with countless alien races living peacefully under one banner. So why haven't we seen them? Well, perhaps they believe we first need to figure out the importance of cooperation for ourselves, to learn from our own history, before they talk to us. A belligerent species is of no use to the galaxy. So, until we learn to live in peace, advanced aliens may not want to share their good stuff with us, especially things that could be used as weapons. Perhaps they think we'll either figure it out on our own or destroy ourselves. Either way, they're staying out of it for now. Sometimes, words are not enough. You have to experience things for yourself. There may truly be a galactic family out there, waiting for us to join. So, after all this discussion, the core message is this: the universe is vast, and alien life very likely exists. It's only a matter of time before we meet them. This could be a momentous event, and the outcome depends on the choices we make. We all hope for peaceful exchange and cooperation with aliens to share in the mysteries of the universe. But ultimately, the search for aliens is also a search for ourselves. What if one day, it's our turn to be the aliens, arriving on another planet, facing life that looks up at us? What will we do? This is something we must think about carefully, because our actions today may determine how the cosmic family views us and treats us tomorrow. I believe that one day, we will find aliens. But to ensure a good outcome, we must first become the kind of civilization we hope to meet: friendly, cooperative, and peaceful, not one of plunder and war. After all, who doesn't want to be treated with kindness?